name's True Sheriff, and I'm talking about Lab 1 for Physics 2. So the purpose of the lab was to model tape using GlowScript to explain what is being observed in the real world. So on the left is what was happening in person. I got two pieces of tape that were about 8 inches long and used one piece of tape to make the other tape float above it. And then I modeled it with GlowScript using the coding language Python, and that is seen on the right with the two point particles. So the assumptions are that there's no drag, it's a closed system, acceleration due to gravity is g, which is 9.8. We're supposed to treat the tape as a point charge for the coding, and you're supposed to assume that each piece of tape has the same magnitude of charge. So the main physical principles are that force of gravity equals mg, electric force equal to kqq divided by r squared, and force is equal to dp dt, of course. So the main result was that I found Q to be 7.467 times 10 to the negative 9 coulombs, and this was found using these values for the tape: length 0.2 meters, width 0.02 meters, mass 0.2 grams, and the distance of the two tapes away from each other where this happened was 0.016 meters. The system is the two pieces of tape. The surroundings are everything else, so my hands, the air, the thing that was holding up the one piece of tape. The initial conditions were that velocity was 0, time equals 0, both objects were still, and the force of gravity was equal to the electric force, and that's why the one was floating above the other. So those are my coding details, and so we got ball mass, which is 0.2 grams, and then the net force is on that piece of tape is the electric force minus gravity, and that was equal to 0 because it was floating and there was no acceleration. UFPES is just the k value, it's the 4 pi epsilon naught thing, and the coulombs of electron are 1.6 times e to the negative 19, g is equal to 9.8, and then there's some other values, but basically the purpose was to find Q, and at the bottom of it you could see that Q was equal to the square root of force of gravity times distance squared divided by UFPES, and then basically when I run this program it prints out that value as you see below that equation. Similarities and differences between the model and predictions. Basically the main difference is that for the coded model we treated it as a point charge, and in real life it's obviously not. This tape is long, it's 8 inches long, and you got two of them, so yeah, that's the main difference. But they're similar in the way that they both interact in a very similar way with the electric force. Potential source of error in measuring the tape length, and tape mass not being exactly 1 gram per meter. Also just things like me setting up the tape and me not exchanging electrons with the tape while I'm handling it. That could interfere with the charge of each of them. So what if electrons and protons switch charge? Essentially everything would still be the same because the net charge would have to be the same, and opposite charges would still attract each other. So even if if the pens goes from negative to positively charged, it's still going to attract the opposite charge.
Why is it important to handle the charged tapes as little as possible? Well, the answer to that is that the more you handle it, the more you send electrons from your body into that. And overall, you are also touching the floor. So then you're going to ground the tape. You don't want to do that. Well, what happens when you charge tapes into contact with your hands? As I said, you're going to ground them. And if you ground them, they're going to lose their charge.